What's up guys? So today we'll be looking at triangles. So what is a triangle? Right, so triangle is a polygon on a plane having three sides, three straight sides and three angles. So the internal angles add up to 180. Now we look at groups of triangles. So we can divide triangles into groups by looking at their sides and by their angle. So triangle with three same sides are called an equilateral triangle. They happen to have three same angles as well, all of them which are 60, and they have three lines of symmetry. Next is the isosceles triangle. This triangle have two same sides and two same angle on each side. Right, it happens to have one line of symmetry only. Next, for triangles which have all three different sides and all three different angles, that's called a scalene triangle. That spells S-C-A-L-E-N-E, scalene triangle. Next, we look at angle-wise. So, for triangle with angles less than 90 degrees, all of them, those are called an acute triangle. So this is an example of an acute triangle. And for triangle having one angle that is 90 degrees, that is called an right angle triangle. And lastly, for a triangle with one obtuse angle, meaning one of its angles is between 90 and 180, we call those as an obtuse triangle. Okay, so back to this triangle. We want to further dissect it into several parts. Just like circle, we have radius, we have diameter, we have chords, right, or chord, either way. So from this dot, this point, this angle or this point, this vertex corner, whichever you want to call it, we will draw a line to this side. Right, I'll use my Sharpie here for a clearer picture. Right, so this line we'll call is a Cevian. We call this line a Cevian. Okay, next, moving on. Now I'm going to place a foam on top of it because I can reuse this triangle again and again. Okay, if we measure this length and draw its midpoint, okay, it happens to be 8, so I draw a midpoint at 4, and we draw a line like this. We could draw this here. Hope it's clear. Okay, we call this as a median. And if we repeat this on all three sides, we'll get a center point right here. Now this point happens to be denoted as G because it is the center of gravity, meaning if I take this triangle up and I place it on my finger with this point on top of my finger, I can balance the triangle on my finger. So this is the center point, center of gravity, or also known as the, let me pull this out. This point is also known as the centroid. Okay, moving on. If I draw this point, right, perpendicularly downwards, like this, such that this point is 90 degrees. Okay, This will give us the altitude. This line is the altitude. Let me draw one of it. Okay, this line would be the altitude. And the same thing, if we repeat this on all three sides, we are actually going to get another center right about here. This center will be denoted as h for height, right? So this is the height respective to this base. So if you want to calculate the area, it will be half the base times this height length. Okay, so this center is called this center will be called an orthocenter point. Okay, so the next point I'm going to show you is called the circumcenter point, right? So for the circumcenter point, we first draw a perpendicular bisector. So just now here is 8. Draw this perpendicular bisector, bisect the line perpendicularly down. Right, so we got this line right here. Ooh, I need to be careful not to shake the point too much. Right, so I then repeat 2 more times to get 2 more perpendicular bisector such that we are left with this point. So this point right here will be our circumcenter point. What does this mean is that from this center to one of the point here, we could draw this a circle and close it. Right, so it will be something like this. So this point can form a circle that will surround the triangles nicely with the triangle points touching the circle. So I'm going to use my Sharpie and gently trace across this circle I formed. Okay, so this circle is what we call the circumcircle, and the radius, well, so this will be its radius, will be called, well, obviously circumradius. Okay, next is the incenter. So to do an incenter, we draw an angle bisector, which is rather easy when you have a compass. Okay, so you draw these arcs over here. You have 2 intersection points. Extend your compass a bit. Right, so draw an arc from the center here, this intersection point here, and this intersection point here, respectively. Don't change your compass width while doing so. And you get this intersection point. From there, we join this point and the original point. Here you get this angle bisector. A line bisect the angle equally, right? So I'm this thin line, right? And we'll do the same for this part here. Now later you will see a flaw I've made. The point should be called an incenter, not an incircle. I hope you know that. Well, you'll see later. Okay, so there's this point here, this point right here. I'm gonna pull this out gently. This point right here is called an incircle, meaning as per the circumcircle, I can draw a circle gently around this triangle, right, and draw a circle around it with the triangle side tangent to the circle. And there we have it. Let me rub away the excess part, leaving one radius. Okay, so angle bisector will result in incircle, and perpendicular bisector of sides results in a circumcircle. Okay, so this is an incircle. The center would be an incenter, and this radius would be an inradius. Right, before that, let me trace it out. The circle. Right, so we are not done yet. Last but not least, let's extend this side and this side to give a two longer sides and one shorter side. Okay, here we have an angle over here, let's call it A, and an angle over here, let's call it B. So let's bisect these two angles. Now if you want to bisect the third angle, feel free to do so. It is the internal angle opposite to the both of the external one. And here, resulting in this point right here. Supposedly this is an excenter. Now let's draw an excircle. Right, so because my tools are not very accurate, I got this outer part, but if you use a computer, it will be the tangent point to all three sides. Right, so let me trace out the circle. I'm gonna cheat a bit. And there we go. So this is an excircle. This point right here is an excenter, and this line right here is an exradius, because it's the radius of this excircle. Right, and there we have it. Okay, now let's look back at this medium part. Right, so let's take the centroid and the orthocenter. Let's overlap them. As you can see here, let me move it until we overlap them, shall we? Okay, so okay, now we take our orthocenter or altitude line set. Okay, and then we take the circumcenter set, place it right here. Now you can see right here we have three points. I'm going to make it stand out to you. Okay, as you can see here we have 3 points. Okay, one is from the circumcenter point. Let's put that O right here. Another is from the median. This is G, and the other is from the altitude or the orthocenter. Let's put that H. Let's move these three out. Oh, messy. Okay, and we are left with this. Now these 3 points is collinear, we can join them up. And this line, we call this the Euler's line. Now it's pronounced Euler, not Euler or ruler, right? And there we have it. This is all the parts of a triangle. Now if you feel like you can't remember all these points, well, there is a song in the next 3 minutes. And without further ado, let's go. We were all young when we first learned it. Close my eyes and a flashback starts. I'm standing there, holding pencil and a ruler there. Draw 3 lines on 3 non-collinear points. Draw 3 straight lines and close the plane, a triangle. Little did I know that this is isosceles, this is right angle, and 3 same side is equilateral, and there's acute and obtuse scale, and 3 different sides. Let's dissect from a point to a line, resulting in a Cevian. If it just midpoint, it becomes median. Draw 3 median, you get a point G, just like a center that is called centroid. So I draw 7 normal to the base, got his height respective to base to 2 more times. Got an orthocenter point. You get an incenter, you draw 3 angle bisector. You do the same to get an excenter, then you draw an excircle, tangent to all 3 sides. One more time, from a point to a line, resulting in a Cevian. If it just midpoint, it becomes median. Draw 3 median, you get a point G, just like a center that is called centroid. To get a circumcenter, you draw 3 perpendicular lines, bisect each of the sides. The circle will touch all 3 points, and I say from a point to a line, resulting in a Cevian. If it just midpoint, it becomes median. Draw 3 median, you got a point G. Here are the parts that less overlapping: circumcenter, centroid, and the orthocenter. These are the 3 points that is collinear. Join these 3 points